Welcome again. In this lecture, I will discuss the Parseval identity for the Fourier series and then we will try to solve some question. So let us define Parseval identity. Let fx be a Fourier series defined in the let fx be a function, not Fourier series. Let fx be a function Welcome again. In this lecture, I will discuss the Parseval identity related to Fourier series and we'll try to solve some question. So, Parseval identity. Let fx be a function defined in interval c, c plus 2l, where fx is periodic or period 2l. Then we know that the Fourier series of fx is Fourier series of fx is fx equal to a0 by 2, n equal to 1 to infinity an cos n pi exponent l plus n equal to 1 to infinity bn sin n pi exponent n. So this was your Fourier series in the interval c, c plus 2n. Now Parseval identity is Parseval identity is 1 upon 2l. I am just giving the formula, I am not going in the proof. And this is equal to 1 upon 2l c to c plus 2l fx whole square dx equal to a0 square upon 4 plus half summation n equal to 1 to infinity an square plus bn square. So this identity is known as Parseval identity. That means 1 upon 2l and the limits of the interval c to c plus 2l fx whole square dx equal to a0 square by 4 plus half the sum of the squares of the an and bn. So now if suppose that c equal to minus l, if c is minus l, then the length of the interval will be 2l and interval will be minus l to plus l. So if c is minus l, note if c is minus l, so if c is equal to minus l, then Fourier half range, let us compute cosine series. Then Fourier half range cosine series will be, so our c is minus l to l, so this will be from minus l to plus l. As the function is even, so this will be your 2 times, so this 2 will be cancelled. So we will have 1 upon l 0 to l fx whole square dx equal to, as we are computing the half range cosine series, so for the half range cosine series our bn will be 0. So in the right hand side we will have a0 square by 4 plus half an square. So this will be your Fourier series. So this will be your Parseval identity when we have to compute the Fourier half range cosine series. And the Fourier half range, and for if the function is second, now if c is equal to minus l, then Fourier half range sine series. That means when the function is odd. Now the Fourier half range sine series will be, again the left hand side will be half 1 by L fx whole square dx. Now as we have to compute the half range sine series, so our a0 and an will be 0. So in the right hand side we will have half summation bn square. So this will be your Parseval identity when the function is odd, or you can say that when we have to compute the half range sine series. So let us solve one question related to this half range series. Question: find Fourier series of fx equal to x square in the interval minus pi comma pi, and deduce that summation 1 upon n to power 4, and deduce that, or you can say that prove that this is equal to pi by 4 upon 90. Summation 1 upon n square equal to pi power 4 upon 90. We know the value of summation 1 by n square, but now we have to evaluate the value of summation 1 by n4. So we will need the Parseval identity. Solution: let us compute its Fourier series. As fx is even function, because fx is even function, so our bn will be 0 and a0 will be 1 upon pi minus pi to pi fx dx. So this will be your, because function is even, so this will be your 2 upon pi 0 to pi x square dx. And now integration of x square will be x cube upon 3. So this will be your x cube, that means 2 pi square by 3. This will be your a0. an equal to 1 upon pi minus pi to pi fx cos nx dx. So this will be our, because function fx is even, so we have this term. Now our fx is x square, so an will be x square cos nx dx. Now using the Bernoulli rule of integration, we will have x square into sin nx upon n. Then differentiation of x square is 2x. Integration of sin x will be minus cos nx upon n. So we will have n square. Then we have plus sign. Then the differentiation of 2x will be 2. And the integration of cos nx will be sin nx upon n. So this will be your n cube. And the limits from 0 to pi. Now the first and third term will be 0, because sin n pi and sin 0 are 0. Now from here we will have the upper limit, so this will be your 2 upon pi, and this is your minus minus plus, so this will be your 2 pi cos n pi, and cos n pi is minus 1 to power n, so this will be your 4 minus 1 to power n upon n square. So this is our an. Therefore Fourier series is a0 by 2 n equal to 1 to infinity n cos n pi. As our a0 was 2 pi square upon 3, so this will be your pi square upon 3, and n equal to 1 to infinity n is 4 minus 1 to power n upon n square cos n pi. So the Fourier series is this one. Now we have to deduce the sum of summation 1 by n power 4. Now as we are getting summation 1 upon n square from this Fourier series, so it is not possible to find out summation 1 upon n power 4 directly using this result. So let us use the Parseval identity. Using Parseval identity, we get Parseval identity was 1 upon 2l, and then this was your 1 upon l 0 to l fx whole square dx equal to, as the function is given, so in the right hand side we will have a0 square by 4 plus summation 1 by 2 an square, and n will be from 1 to infinity. Now in place of l we have pi, so this will be your 1 upon pi 0 to pi. Fx is x square, so this will be your x power 4. Dx is, now a0 was 2 pi square by 3. This was your a0. Now, so a0 square will be 4 pi square by 9. So this will be pi square by 9. Sorry, pi power 4 upon 9. And an, this is your an. This term was our an. So its whole square will be, the whole square of this term will be 16. Minus 1 power 2n means plus 1 divided by n power 4. And summation will be from 1 to infinity. So in the left hand side we will have the integration of x power 4 will be x power 5 upon 5. So here we will have pi power 4 because 1 pi will cancel. 1 5. From here we will have pi power 4 upon 9. And this is your 8 times summation 1 to infinity 1 upon n power 4. Okay. Now we can see that this is our 9 minus 5, that means 4. 5 pi power 4 divided by 45 is equal to 8 times summation 1 upon n power 4. So this will be your 2 and here we will get 90. So summation n equal to 1 to infinity 1 upon n power 4 will be summation of this will be pi power 4 upon 90. So this is your answer. And we have to prove that this summation is equal to pi power 4 upon 90. Next question. Find half range cosine series of fx equal to x in interval 0, L, in the interval 0, L, and prove that this summation n equal to 1 to infinity 1 upon 2n minus 1 power 4 is equal to pi power 4 upon 96. Okay. Please note that here the function is odd, but for the when the function is odd, then we will have to evaluate only bn. But we have given that we have to find out the half range cosine series. So let us find the cosine series. Here we are not going to find the sine series. So fx equal to x. So our a0 will be, for cosine series we will not evaluate bn, we will just evaluate a0 and an. So our a0 will be 1 upon, here we can see that as we have to use the half range series, so this will be a 2 upon n, 0 to n, fx dx, and in place of fx we have x, so here we can see that integration of x will be x square by 2, so this will be L. So a0 is L. Then our n will be 2 upon n, 0 to L, fx cos n x, cos n pi x upon n, px. So this is equal to 2 upon L, integration 0 to L, fx was x. Now integration of this will be x, integration of cos will be sin n pi x upon L. Then in the denominator we will have n pi upon L, so this will be L upon n pi. Then we will have minus sign, differentiation of x will be 1, and the integration of sin will be minus, so this will be plus cos n pi x upon L, and in the denominator we will have a term L upon n pi, n upon L, n pi upon L, so this will be L square upon n square pi square, and the limits from 0 to L. This is inside the angle. Now here you can see that if x equal to L, then this term will be sin n pi, and sin n pi is 0. So this is 0. Again, if x is 0, then we will have sin 0. So this term will be 0 for both upper and lower limit. So from here we will get 2 upon L into L square upon n square pi square, Now if your x is L, then this will be your cos n pi, which is minus 1 to the power n. And if x is 0, then this will be your cos 0, which is your 1. So this will be your 2L upon n square pi square. In the bracket we will have minus 1 to the power n minus 1. Okay. Now if n is 1, this will be your minus 1. So minus 1 will be minus 2. So this will be your minus 4 times. Now if your n is 2, then this will be your plus 1 and this is your minus 1. So this will be your 0 if n is even, and this is your minus 2. So this will be your minus 4L upon n square pi square if n is odd. So your A0 was L and n is this one when your n is odd. Hence by Parseval identity, or therefore Fourier series will be fx equal to A0 by 2. So A0 was L, so this will be your n by 2. Summation n equal to, now when n is odd we have the value, in case of n is even we have the value as 0. So let us write it as n equal to odd number. Then for this odd number the value of n is minus 4L upon n square pi square, and here we will have cos n pi x upon L. So this is your Fourier series. Now let us deduce the sum of the result, sum of that number. So therefore by Parseval identity, which was your 1 upon L, 0 to L, fx whole square dx equal to A0 square by 4 plus half summation n square. So by this Parseval identity, our fx was x, so this will be your x square, and here our A0 was L, so this will be your L square by 4, and here your an is minus 4L upon n square pi square. So its square will be 16 L square upon n power 4 pi power 4. So now the integration of x square will be x cube upon 3. So this will be your L square upon 3, because one L will be cancelled. From here we will have L square upon 4, and this is equal to 8 times L square upon n power 4 pi power 4. Now this will be your L square upon 12, and in the right hand side we will have 8 L square upon pi power 4 into summation 1 upon n power 4. Now this is only when your n is odd. This is true when n is odd. This is true when n is odd. And this is true when n is odd. So this will be your pi power 4 upon 96 equal to n equal to odd number, then 1 upon n power 4. So this is your answer. And we can also write it as n is odd. So we can also write it as pi power 4 upon 96 equal to n equal to 1 to infinity 1 upon 2n minus 1 power 4.